Hello everyone, I'm Brad Henson. And today I'm excited to introduce a new project I'm getting involved in, along with Adam Costero over at the K4 Fish YouTube channel. Adam approached me a few weeks ago and was describing all of the things that it takes to keep up with a reef aquarium. You know, temperature sensors, pH sensors, the different lighting systems, auto top-off systems, you know, all these things that need to be plugged in, or little wind-up timers that have to be set. It's a very manual, cumbersome process. And I thought, well, we could definitely do something that can control one of these aquariums, or at least control the inputs and outputs to the aquarium using something like an Arduino microcontroller. So in this video, I want to throw up the whiteboard, go over a quick list of requirements, an overall sketch of the design, and then, you know, maybe do a little show and tell for where we are right now with the project and with some of the components that we've purchased. So here we have a quick list of our requirements and an overall sketch. The main sensors we're looking at using right now are to measure for the pH in the main tank. We want to measure the temperature in the main tank. And we also want to measure the water level in both the main tank and the reserve tank, so that we can use this as an auto top-off system as well. Additionally, we want to control everything through a an outlet box, a surge protected outlet box. It's got to have at least 9 outlets. It's going to be controlled using relays connected to the Arduino. And this box has to have the same level of surge protection that you would find in any everyday surge protected outlet strip. We're going to want to be able to view the status and update the configuration, and then also provide manual control via a web interface. Additionally, we want to try to have some sort of heads-up display that can be mounted near the tank, so it's a quick look and see what the different measured levels are. So for this intro video, I thought we would take an opportunity to go over some of the components that we've already purchased and plan to use in the final build. This is by no means all-encompassing. However, it does represent the bare minimum of components to do a technology assessment to ensure that we had the capability of actually building a final product. So a quick rundown of what I have here on the bench. We have our standard surge protected outlet strip, a real-time clock, 8-channel relay board, our level measurement sensors, pH sensor along with the pH circuitry, an Arduino Mega 2560 with Arduino compatible network shield, and then a water sealed temperature probe. Now, I mentioned during the requirements list that for our outlet box we want the same level of surge protection that you would find in a modern everyday outlet strip. Now, there's 2 ways of going about doing that. We can either design a circuit for it, something custom and put in our project, or we can reutilize what's already out there. I've chosen to go the latter, and if we open up our outlet strip, you can see I've already pulled the circuit board out. We'll be able to easily reutilize the internal circuitry with all of the poly fuses and the on-off power switch for that circuit. Now, the output of the surge protected board is going to go into an 8-channel relay. These relays are fairly inexpensive. You can pick them up for just under $10. They're designed to work with Arduino microcontrollers or other microcontrollers out on the market. You have your control pins on one side, and then all of your line neutrals and grounds would go into the other side of the relay. These are rated up to 10 amps each, and so it'll be more than sufficient for our purposes. As I mentioned earlier, we're going to want to control our lighting system, which will include being able to tell what time of day it is to depict that type of light. Now, the Arduino microcontroller has some programming logic in there for determining how much time has passed, but it's not very good at, you know, acting as a clock, especially when the system has to restart. So to accomplish that, we're going to use a real-time clock dedicated circuit. Again, these are fairly inexpensive. You can buy them on eBay for around $5. Adafruit and SparkFun both have versions of these that are really nice for around $10. They're Arduino compatible. They've got libraries out there that make them easy to use, and so this will work real well for us. monitoring and controlling the water level of our aquarium is especially critical. With all of this evaporation, we're constantly having to pump water from the reserve into the main tank, and so it's especially critical that we have the best quality sensors that we can for this purpose. Now, initially we were looking at some industry standard float switches, mechanical switches, and then we came across these Mylon produced E-tapes that work on a pressure sensitivity basis and then output across 2 pins to our microcontroller. There are existing sketch libraries that we can reuse for our software, and so this should be fairly easy for us to implement. When we first started talking about putting together this Reef controller, we went out on the net and looked at all the different possible sensors that could be used in this project to meet our needs. Coming across our first pH sensor at SparkFun, there was a little bit of a sticker shock. It was over $100. We thought, my God, if it's going to cost $100 to do pH readings, no wonder these commercially available tank controllers are so expensive. However, doing a little bit more research, we were able to come across this analog pH sensor from DF Robot for a much lower price. It's $30. Comes with a custom BNC connected circuit board for controlling it and connecting it to our Arduino. This isn't stated to be a lab grade pH sensor, and so we're going to do quite a bit of testing over the coming months to ensure that the readings that we get from this are going to be up to expectations. So for measuring temperature in our main tank, we have a waterproof DS18 Bravo 20 digital temperature sensor. These are fairly common, they're inexpensive, you can get them for $10 or less. Definitely check out places like Adafruit, SparkFun, eBay even. It's a digital sensor, it has a single output. It's also widely used, so there's a lot of example software out there that we can also implement into our own program. Now, your budget for this project could easily explode with the Arduino setup. Buying an officially branded Arduino Mega will run you about $50, and then of course a network shield is another $30 or $40. For our purposes, we went on eBay and we found what's known as Arduino clones. They use the same circuitry and are basically identical circuit boards. However, the cost for mass production out of China is a little bit lower, and so we've only spent $20 on the Mega and $10 for the network shield. So all of this hardware isn't going to do us any good without some sort of user interface that presents us with the information, allows us to configure the setup, and also manually control our outlets for when we're doing maintenance on our tank and things like that. So what I've done here is set up a quick demonstration of where we're at in terms of the software build. Now, as mentioned before, we're going to be using a web interface so that we can access this application anywhere on our local network, but then also do port forwarding through our local router so that we can access it from anywhere in the world via the internet. And so our interface is going to be HTML driven off of the network shield. It's going to be written so that it's easily consumable from a cell phone. As you can see, in the top portion of this application, we'll be displaying our sensor information, temperature, tank and reserve, water level, and then also our pH information. We have control over the individual sockets or electrical outlets from our outlet box. We'll be able to put it into an auto configuration mode and then manually turn those on and off when we want. We also want to be able to give the user the ability to configure some of the more important aspects, so that if we decide that the temperature that was set was a little too high or a little too low, we want to be able to adjust that temperature or adjust our desired tank level. Another important thing is be able to set an offset to when our lights are coming on and off, maybe adjust for daylight savings time. And so for a quick demonstration, what we have set up on the breadboard are a couple LEDs connected to each one of our input-output pins. Now, each one of these LEDs represents a connection to a relay in the outlet box. And so, as you can see, as we turn our each outlet on will illuminate the LED, and then we also show a status, an illuminated status on the web application. Now, if you're interested in following this project, all the information from now in the introduction through the build process, the software development process, is going to be maintained on bradhenson.com. If you go to the main menu, projects, you'll see K4 Reef Controller. Click on that, and then you'll be able to find all of the information as it's updated. Also, make sure you check out Adam's K4 Fish YouTube channel. He has a lot of great videos covering his aquarium setups and reef setups, along with equipment reviews and how he's installed some of his components on his tanks. You can also follow this project through the bradhenson.com YouTube channel. That's youtube.com/user/Bradford Henson. As we update videos for using and configuring each of the sensors or progress through the build, we're going to be including these videos on both the K4 Fish YouTube channel and the bradhenson.com YouTube channel. So make sure you subscribe to both and press the like button. Thank you very much.